Welcome back to the sessions on basics of Matlab. In our last session, we have discussed visualization in Matlab, how to plot line charts, bar charts, contour plots, surface plots, right? I have demonstrated all these plottings in Matlab with examples. In the end, we have discussed the use of this mesh grid function, right? So this mesh grid function basically it converts two independent 1D coordinates into 2D coordinates. That is the idea of this 2D means it will give the list of x and y coordinates in 2 dimension, right? Using this mesh grid function, the output of mesh grid function will be supplied to your contour plot or surface plot, right? Means not directly. We'll use the output of this mesh grid function to generate the third dimension. Then we have given these 3 dimensions to this contour plot or surface plot. Alright, so now let us move on. So in this session, our focus will be on inbuilt functions supported by Matlab for algebra, for calculus, for differentiation, and for integration. Whatever is possible that will be covered in this session. The rest will be covered in the next session. Okay, we'll start. So let me open a new script. So we'll start with solving some algebraic equations in Matlab, right? So first, so you see, these are algebraic equations. They are generally represented symbolically, right? When we write with pen and paper, we write like x square plus 5x plus 3 equals to 0. Now what is the solution for this equation, right? This is an algebraic equation. What is the solution for this equation? How to solve, right? So for that, in order to define this equation, first of all, x cube plus 5x square plus 2x plus 0 like this. This Matlab supports something called symbolic variable. So sims, you can define symbolic variables. So sims of x. That means we have defined a symbolic variable. First let me save this file as practice. Let me overwrite this file only every time, right? So we have defined a symbolic variable. Now let us solve a simple equation, simple algebraic equation. X minus 5 is equals to 0. Let me solve this, right? Now if you solve this, what happens? We'll see. Or what is the error? It says might be invalid. So here you have to give double equals to. Then it will take, right? Since it is a symbolic equation, this is not assignment, it is equation. X minus 5 is equals to 0. It is equation, right? That's why we used this double equals to here. It is not assignment. Equals to means assignment operator, right? X equals to y. That means like this. Let us say x equals to 2 and y equals to x. That means you are assigning the value of x to y. So x, this single equals to will be treated as assignment operator. That's why we used double equals to here, because this is a equation. Now let us solve this. Okay, let me directly run this. You see, answer is 5. You can store this value somewhere also, that is also okay. You can store it in y, right? And then we'll see the value of y and all these things. You see, y is 5 now. So this way you can solve algebraic equations. Now let us try to solve some other algebraic equations, more complex equations. This is very simple equation, right? X minus 5 equals to 0. We will solve some complex equations now. So let us define 2 symbolic variables, u and v. If you want to define multiple symbolic variables, simply write sims list of symbolic variables. So that the list of symbolic variables are, let us say, u, v, t. Now let me define a equation, solve So you see, you can directly define something. Otherwise, let me write equation. Let me define an equation. EQ equals to, let me define the symbolic equation. V minus U minus 3t square. 3 times t square. Right? This is V minus U minus 3t square equals to 0. Equals to means, how should I write? I should write like this. Right? Now if you want to solve EQ, this equation, you can solve this equation. Suppose you want to solve this equation with respect to some variable. Let us say I want to solve this equation with respect to u. You can pass that also. Okay, let me delete u. Now let me run this. We'll see what happens. See, I have solved this equation with respect to u. So the result is v 3t square minus, no, this is, I am solving this with respect to u. So therefore the result is v minus 3t square. Right? So instead of defining like this, you can directly write, you can avoid this sentence and you can directly give here. In place of EQ, you can directly give here the equation itself. There is no need of this this one, semicolon also. Now you can run it again. You will get the same result. 3t square minus 3t square plus v. Let me maximize this. Okay. Let me clear everything. Let me clear the workspace. I have cleared. Okay, now again we'll go ahead. Now let us say we have this equation. We have solved this equation, right? Now let us try to solve some other equations. Let us say you want to find roots of some equation and so on, right? We have already seen how to find roots of equation earlier, right? How to find roots of equation? You can represent the polynomial as vector. You can give the vector to a function named roots. It will return roots of the equation. This we already solved. Let me repeat it again. Suppose your equation is x minus 5 is equals to 0. This can be represented as a vector and we can pass the vector to this function roots. So let me pass directly the vector. What is the vector? 1 minus 5. What are the roots? You simply run this command, you will get the roots of the equation. What is the root here? X minus 5 is 0, so root is 5. Right? This we already discussed. Now we will see how to solve roots of equation here using the solve function. Using this root function we have already discussed. Now let us say how to find roots of equation using the solve function. Let me define symbolic variable x, right? Let me define an equation. Let us say x square means, where is this? X square, right? Minus 7x, let us say minus 7 times x plus 12 is equals to 0. This is the equation that we have defined. Let me give a semicolon also. Now let us solve this equation. Solve this equation EQ. Now what happens, you see, when you solve this equation, it was directly giving the roots, right? 3 and 4 are the roots. So therefore using solve also you will get roots using this solve function. Only thing is you have to define a symbolic variable x, then you have to define the equation. You pass this equation to solve, that's all. Right? So this is the first root and this is the second root. Similarly, you can give various other equations and we can find the roots. Now let us give some higher order algebraic equation and let us try to find the roots of the equation. Now let us say, let me remove this altogether. Let me directly pass in the solve function itself. Let us say you want to find roots of an equation. Let us say x minus 3 times x minus 3 times x minus 7 whole square, x minus 7 whole square, right? This is equals to 0. This is the equation. You want to directly solve, you want to directly find roots of this equation, simply give it to solve function. This solve function will return all the roots of the algebraic equation, 3, 7 and 7, right? So this way we can find all the roots of the equation. First way is using roots function that we have discussed yesterday. The second way is define a symbolic variable, right? And then pass it to this solve function. So here it is very simple. Let us say you want to give some complicated equation here. Rather than this, you want to give some x power 4, let us say x power 4 minus 7x cube, 7 times x times cube, 7x cube, plus 3x square, 3 times x times 2, 3x square, minus 5x, let us say 5x, plus 9 equals to 0. So this should be small. Now let us say you want to solve this, you want to find roots of this equation. This is, looks somewhat complicated, x power 4, something like unrecognized. Oh, this is s, this should be 5x plus 9 equals to 0. You see, these are the roots of the equation. We will find all the roots of the equation. What happened here? Root, what is this? X power 4 minus 7x cube plus 3x square minus 5x plus 9 is equals to 0, right? Seven x cube, x power 4, 7x cube is 3x square minus 5x plus 9 is equals to 0. We are directly solving this. Let me clear everything and let me run it again. Okay, all right. So this way you can solve algebraic equations. So Matlab supports inbuilt functions for Matlab supports inbuilt functions for solving these algebraic equations. First way is represent the algebraic equation in terms of a vector, then pass the vector to a function named roots. Second way is define a symbolic variable, then write the equation symbolically, pass the equation to this function solve. So this way you can solve these algebraic equations in Matlab, right? Similarly, if you want to solve a system of equations, let us say linear equations you want to solve, that can be done using this solve command. Now let us see that one. Let us say, let me define two symbolic variables x and y. Let us say you want to solve two linear equations. Let us say 5x, 5 times x plus 9y is equals to 5 comma 3x minus 6y, let us say minus 6 times y is equals to 4. You want to solve these two equations. Let us say this should be small and this should be small x. If you run them, you will get x equals to 22 by 9, y equals to minus 5 by 57. So this way you can give not only linear equations, you can give some system of equations, not necessarily linear. You can use system of linear equations, and then you pass this system of linear equations to this solve function. The solve function will simply solve them. Let us give something with three variables x, y, z. Let us say, let me define the first equation, x plus 3 times y minus 2 times z equals to 5. Let us say this is the first equation. Similarly, 3 times x plus 5 times y plus 5 times y plus 5 times y plus 6 times z is equals to, let us say, 7. Similarly, let me give third equation, 2 times x plus 4 times y, 4 times y, right, plus 3 times z, plus 3 times z is equals to 8. You can simply solve this in values of operator. Where is this? 11. This should be 1. Any issue anywhere else? No. I hope it is clear. So if you run this unrecognized, so there is capital X, it should be small x. If you run this, you will get an output like this, right? You can check the value by opening x, y and z. X, y and z. So this way we can solve this system of equations, a single algebraic equation, system of equations, system of linear equations, all these things in Matlab. Right? Similarly, Matlab supports various other functions such as expanding an equation, a symbolic equation, factoring a symbolic equation, and simplifying a symbolic equation. Now let us define a symbolic variable named x, let us say, and you want to expand x minus, let us say, x minus 5 times, let us say, x plus 9. You simply give it to expand function. The expand function will take care of this one. It will expand, you see, and it will return the expanded result, x square plus 4x minus 45. So similarly, you can expand anything. You can expand, let us say, sine 2x, 2 times x, sine 2x, you want to expand. This would be small x. Let us run this one. See, sine 2x is 2 sin x cos x. Similarly, if you want to expand whatever you want to expand, you simply give here to this expand function. This expand function will take care of this cos x plus y. Let us say cos x plus y. Let me define one more symbolic variable, y. Right? This is cos x plus y. Cos x cos y minus sin x sin y. So this way, you see, the expand function. Suppose if you do not remember something, you simply give it to this expand function, it will give you. No need to remember everything. Simply give whatever you want to this expand function. This expand function will give you the result. So in addition to this expand function, this Matlab supports two more functions called factor and simplify. What is this factor and simplify? Let us give it this x square plus 4x minus 45 to factor. Then what this factor will give? The factor, you see what it will give. What it will give? Factor. What is this factor? I am giving this to factor. What is this? This is the result of x minus 5 times x plus 9. Now let me factor and let me show you what it will return. It is returning x plus 9 and x minus 5. So it is factoring. It is factoring this equation into x plus 9 and x minus 5. Right? So not only expansion, it factors also. If you give an algebraic equation, it will factor out. Similarly, we have a function for simplify. Let us say you have a equation with numerator and denominator. You want to simplify the equation. This can be done using this simplify. Let us say we have a x power 4. Let us say x power 4 minus 16. This is the numerator. Let us say this is your numerator. And where is this? This is your numerator. And let us say we have denominator. Denominator is x power 2 minus 4. Let us say this is your denominator. Now what it will result? Let me clear it. If you pass it to the simplify function, it will solve this numerator and denominator, this equation. It is giving x square plus 4. This is the use of simplify function. So Matlab supports all these functions: solve, roots, expand, factor, simplify, all these functions it supports. So this is about algebra. Now let us move on to calculus part. So Matlab supports many inbuilt functions for limits, for calculus, for integration, and so on, right? So let me give a brief overview about these functions. So let us start with limits. So Matlab supports built-in functions for limits. So let us define a symbolic variable, sims of x. Now let us try to find limit of some equation, symbolic equation. So this Matlab has an inbuilt function limit. We can pass the symbolic equation to this limit function, and it will find out, it will compute the limit. Let us give something. Let us say x cube plus 5 divided by, let us say, x power 4 plus 7. X power 4 plus 7. Now if you give this, and if you ask the system to find limit, it will simply give the limit as 5 by 7. As x tends to 0, as you can see, this is x cube plus 5 divided by x power 4 plus 7, right? Therefore the limit as x tends to 0, the limit value reaches 5 by 7, and the system was returning 5 by 7, right? So similarly, you can say as x tends to 1, what is the value of this, and so on. So let me give one more, this one. Let us say x minus, let me give one more thing, x minus 3 divided by x minus 1. Let us say x minus 1. What is the value of limit as x tends to 1? Let us say you want to find as x tends to 1. So this can be supplied by simply giving the second argument as 1. So this implies that limit x tends to 1, x minus 3 by x minus 1. What is the value? The answer is not a number. That's all, right? As x tends to 1, this becomes 1 minus 3. This becomes 1 minus 1, 0. That's why it is like infinity. That's why it is giving not a number. The result is infinite. That's why it is giving not a number. Similarly, you can give whatever you want. Let us say you want to give one more equation, limit, different equation. Let us say x square plus 5. I want to evaluate limit of this equation. That's all. X square plus 5 at 3, as x tends to 3. As x tends to 3, as you can see, this is 3 square plus 5. That means 14. So it was giving 14. Right? So this limit function, it will compute the limit of your equation. Right? Now similarly, you can check the properties of limits. Let us say you have two functions f and g. What is limit f plus g? This is equivalent to limit f and plus limit g, right? Let us say you let me write here, paint. You can cross check all the properties here. Let us say you have limit x, we have two functions, f of x plus g of x. We have two functions. So what is the limit x tends to something, f of x plus g of x? It is nothing but limit extends to, let us say, 0 f of x plus limit extends to 0 g of x. All these properties can be cross checked here, right? Let me go. If you want to cross check at least one property, you can do this. Let us say, let me define two functions, right? Let us say, let me define a function f. Let us say the function is 3x plus 5, 3x plus 5 divided by x minus 3, right? Let me define one more function, g. Let us say g is x square plus 1, x square plus 1. Now let me give a semicolon also. This is the first one. Now you can cross check the properties of limits. What is limit extends to 0 f of x plus g of x, limit extends to 0 f of x times g of x, limit extends to 0 or limit extends to some value f of x by g of x. All these properties can be cross checked. Let me check at least one property. Let us say limit. Let me check first. Let me calculate limit f, right? It has let us say extends to 3 or 4, let us say extends to 4. Similarly, limit g as extends to 4. Now let us say, let us calculate limit f plus g as extends to 4. Similarly, you can cross check limit f times g as extends to 4. Limit f minus g as extends to 4. All these things you can cross check. You can check the results. You see, this is the first result, second result. So what is the first result? So this is limit f tends to 4. It is, what is the result? Result is 17. Right? This is 17. Where is the, yeah, this is 17. No, this is only f g. Yeah, this is also 17. Now what is f plus g? It should be 34. What is f times g? It is 17 times 17, 289. What is f minus g? It is 17 minus 17, 0. So you can cross check all the properties by using these limits, right? CLC and clearing the workspace also. So this way you can use the limit function to calculate limits of different equations. So I hope it is clear. So let me quickly go through the integration and differentiation. If you want more details about these limits, you can explore more details about limits. You will get many so much of material in the internet. So let me discuss few things about differentiations. So Matlab supports a function called diff for calculating the differential of some equation. Let me start with something, symbolic variable x. Let me define symbolic variable x. Let me directly give the equation to this function instead of defining the equation and passing the equation to this function. So let me define a function, the equation 3 times x square, 3 times x square plus 2 times x. Let us say 2 times x. 2 times x. So let us run this. What is the differentiation of 3x square plus 2x? Obviously it is 6x plus 2. So it was returning 6x plus 2. And note that it was returning the symbolic result only, right? Here we are, so far we are not working with numbers. We are giving symbols, the system is returning the result as a symbol only, right? Now similarly you can cross check many things in differentiation also, right? You can cross check the rules of differentiation, like what is the differential of a plus b, differential of a by a times b, differential of a by b. All these properties you can cross check by giving two functions, let us say f and g, differential of f by g, differential of f minus g, differential of f times g, and all these things you can cross check. So let us define two functions. So let me define two functions f. Let us say f is x plus 2 times x square plus 3, x square plus 3. You can find out differential of this one by passing it to differential of f. You can run this one. You will get you can cross check, the result will be same as your differential of a times b. It is ab bar plus ba bar. You can cross check this one, right? This is a, let us say, right? This is b. So ab bar, it is 2x, right? That's why 2x times x plus 2 plus x plus 2 times x square plus 3 times 1. So that's why we are getting this result. You can give some complicated equations also here. Instead of, I'm giving only small simple things. You can give complicated values and you can cross check all the results. Now let us, what we do is, let us try to find differential of some other things. Let me give differential of sin x. Will it give or not? We'll cross check. Differential of sin x, differential of cos x, differential of tan x, differential of log x, differential of 1 by x, all these things, differential of x square, right? Differential of e power x, e power means exp of x. I think one bracket. I have to delete this. I have to delete this. Yeah. So you can cross check all these things, right? Let me run this. You can see the result. Differential of sin x is cos x, differential of cos x is minus sin x, differential of tan x is this one, differential of log x, 1 by x, differential of 1 by x is differential of 1 by x is minus 1 by x square, right? Differential of log x is 1 by x, differential of x square is 2x, differential of e power x is e power x itself. You can cross check all these things. You see, I have given this and the system has written, computed the differential and it was returning all those things, right? You can calculate all these things using this differential. It is very simple. Using this simple function diff, you can supply complex equations. It will compute differential of your complex equations and it will return the symbolic result, right? So now, okay, we are able to compute differential of a equation. It is good. Now I want to compute higher order differentials. I want to compute second order derivative, third order derivative, and so on. Can we compute it? Yes, we can compute. So let me give an equation, x times exponential of minus 3 times x, let us say, minus 3 times x. I want to compute the second order derivative of this function. So you can simply pass a second argument saying that I want to compute second order derivative. So that's why I am giving 2. By default, if you do not supply the second argument, it will calculate first order derivative and it will return. If you supply the second order derivative, then it will calculate whatever you give, it will calculate that much derivative and it will return. This is the second order derivative. If you give n, it will calculate nth order derivative. This is the second order derivative of the function that we have given as input. Right? Similarly, you can calculate third order derivative and so on. So far, any questions? No, because it is recorded, right? No, yeah, okay. Okay, so this is the way to compute higher order derivatives, right? Similarly, if you want to solve differential equations, let us say we have differential equations like f double dash plus f equals to minus something, right? If you want to solve differential equations, you can solve differential equations also. Or you can do, you want to check something, you can check. Let us say you have a function f of x equals to 3 sin x plus 7 cos 5x. You want to check whether f double dash plus f is equals to minus 5 cos 2x, whether it holds or not. You can cross check by simply calculating double derivative, right? Let me write here, then it will be clear otherwise. We have some function, let us say f. The function is, let us say 3 sin x plus 7 cos 5x. Now you want to check whether f double dash plus f is equals to minus 5 cos 2x. How will you do? First, define a symbolic variable x. Now define this function 3 sin x plus cos 5x. Now find the second order derivative and then add this f to this one, right? It will give a symbolic result. Now you can check whether this is equals to this or not. Okay, let me show this otherwise. Okay, so we have this function. Now let me define a function. What is our function? 3 sin x, 3 times sin x plus 5 times 7 times cos 5x. This is your function. Now you want to check whether f double dash plus f is equals to minus 5 cos 2x. So let me define f1. What is this f1? Second derivative of f. So second derivative means what? F comma 2. Second derivative of f plus I am adding f. So this is f double dash plus f. Let me define f2. What is this f2? Minus 5 times cos 2x. Cos 2 times x. Now I want to check whether both are equal or not. How to check whether both are equal or not? You write if there is a inbuilt function is equal. You supply two arguments, it will check whether both are equal or not. So let me supply f1 and f2. If both are equal, let me display that both are equal. Let me display that equal. Both are equal. Otherwise, else, what we do? Let me display does not hold. Equation does not hold. Equation does not hold. End. Let me run this one. It does not hold, right? See, this is f1, this is f2. So obviously it does not hold. This is not equal to this one. That means the equation that we have shown here, it does not hold. F double dash plus f is not equal to minus 5 cos 2x. You can cross check all these things using these simple commands, right? Okay, so we have seen differentiations and then higher order derivatives also, second order derivative, third order derivative and so on. Similarly, if you want to find minimum and maximum of a curve, what will you do? You find the differentiation, then you equate it to 0, right? Let us say you have a function f, you want to find the minimum value and maximum value of this function. How to find the minimum value and maximum value of the function? You find the first order derivative, then equate it to 0, then you will get the minimum and maximum values. So now let us see how to find minimum and maximum value of something. Let me define a function f. Let us say it is equal to 2x cube. It is a 2x cube plus 3x square plus 3 times x square, right, minus 12 times x, 12 times x plus 17. Let us say this is our equation, right? This is our function. Now I want to find minimum and maximum value of this function. So before applying derivative and equating it to 0, let me show you the curve of this function. So yesterday we have seen the plot function, right? Plot function takes two arguments, x and y. Then it will plot. But here what we have a symbolic function. That's all. This is 2x cube plus 3x square. This is 3x small x. 3x square minus 12x plus 17. Now I want to plot this. How to plot this? The symbolic function. We have one more function called EZPlot. So this EZPlot function is for plotting a symbolic equation. Let me supply the symbolic equation. Let me show you the result first. Then we will see the minimum and maximum value. So this is the, you see here, this is the curve corresponding to this equation. 3x square minus 12x plus 2x cube plus 17. We got this curve. Now if you see this curve, right? If you see this curve, let us say, if you want to see this curve between some minus 2 and plus 2, that can be done. Because here you see, we are simply supplying the symbolic equation. By default, it was giving from minus 5 to 5. But if you want to see the curve from, let us say, minus 2 to plus 2, minus 2 and plus 2, you can give minus 2 and comma plus 2, you can supply. Then you will get a curve between minus 2 and plus 2. You see here, right? So using this EZPlot command, you can draw the curve. 3x square, this curve you will get, right? Minus 2 and plus 2, we got this curve. Now let us say you want to find the minimum and maximum value of this curve, right? Now how to find minimum and maximum value of this curve? So first find derivative of this function. How to find derivative? G equals to differentiation of f, only one first order derivative, right? With respect to x anyhow. So what is the differential it will give? Now solve g. Solve g will give you the roots of the equation, right? So let me solve this first. So what are the roots of equation? So this is the derivative, 6x square plus 6x minus 12. So the roots of this equation are minus 2 and 1. Minus 2 and 1. Now you can cross check which one is minimum and which one is maximum. Now how to check which one is minimum and which one is maximum? How to check this one now? Now we got two roots. How to check? So this can be done by a command called substitute. Substitute in f the value minus 2. Similarly, substitute in f the value 1. Now let me substitute and see the values. You see, when you substitute minus 2, the value of the function is 37. When you substitute plus 1, the value is 10. That means this is the value at which maximum occurs. So minus 2 is the value at which maximum occurs and 1 is the value at which minimum occurs. The function will have minimum value. Are we clear this one? So we simply applied first order derivative, then solved the equation, solved the differential equation, this one. Then we got two roots. One of them is, you see, one of them is maximum, one of them is minimum. That can be cross-checked using this substitute function. You can substitute the value in function and then you can check whether it is returning the maximum value or minimum value. Okay, so this way you can check maximum and minimum value of a function. Now let us quickly discuss how to solve differential equations. Earlier we have seen how to solve equations, right? Algebraic equations, linear equations, quadratic equations, how to solve using the solve function. Now MATLAB has one more function called dsolve. This dsolve will solve differential equations, but there is a syntax for giving the differential equation as input. Now let us say you want to give a differential equation. Let us say the differential equation is f dash of x equals to minus 2f plus cos t. This is your differential equation, let us say. Or you can say, where is this one? Let me write in let us say we have a differential equation. Let us say f double dash plus 2f equals to 5 sine 3x. This is your differential equation you want to solve. If you want to give this as input to the system, we have to follow some syntax in MATLAB. What is the syntax? The syntax is simple. Let us say this is f double dash x, right? So if you want to give this one, you have to, so what is this? You are giving a differential equation. So you have to write D. D stands for differential. This is, so which differential it is? Second order differential. So you have to give D2. D2f plus 2 times f, right? This is what? Let us say 2f dash. This is 2f dash. Then how we should give? We should give like this. 2df is equals to 5 times sine 3x. So this way we should give. When you are giving a differential, you should write d followed by the number. Number indicates whether it is first order differential or second order differential or third order differential and so on. So let me start with a simple equation and let me tell you. Let us say f dash equals to 5f. This is your differential equation. Now how to solve this differential equation using MATLAB? So dsolve. What is the equation I want to solve? F dash equals to 5x. That means x dash, let us say. So dx equals to 5 times x. 5 times x. Then solve. Okay, some issue. What is this issue? So this dsolve, actually you can directly give equation. Okay, I got. There is this one here. I think I have to give inside this single quote. Right? Now I hope it will work. Yeah. So this is the differential equation. By solving this differential equation, right, it is equivalent to x dash, first order derivative of x equals to 5x. You want to solve. So this is the result. Similarly, you want to solve some other equation. Let us say f double dash minus f equals to 0. Let us say you want to solve. What you want to solve? F double dash. That means d2f d2x minus x equals to 0. Let us say equals to 0. You want to solve this. You can solve it. Similarly, you can supply initial and boundary conditions also. Let us say you want to supply some initial and boundary conditions. Let us say the initial condition is that x of 0 equals to minus 1. Let us say this is f, this is f, this is f. We have one f. F of 0, the initial value of f is something. F of 0 is equals to minus 1, let us say. Similarly, the boundary condition, let us say f of df of, means the first order derivative of f of 0 is equals to 2. You can supply the boundary condition, initial conditions, and then you can give it to this dsolve command. This dsolve command will solve everything, right? You see, this is the result. So using this diff command and dsolve command, you can solve differentiation and differential equations. So in this lecture, we started with a method to solve algebraic equations. So we have defined symbolic variables, symbolic equations, then we have supplied it to the solve function. The solve function itself has returned. Again the output is symbolic. Similarly, we have seen how to solve higher order algebraic equations. We have seen how to solve limits, differentiations, higher order differentiations, and differential equations. So let us continue our discussion in our next session. Thank you.